Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hey guys,
Oh, accidentally double-clicked the intro there. Sorry about that. Welcome to Astronomy Live. Tonight we are going to be viewing a couple of objects. The headline's getting buried again on this one a little bit, so stay with me and we will get around to Comet Atlas. But first I'm taking pictures of Asteroid 1998 OR2. This is another one of interest to a lot of people, because it's a relatively large asteroid that will be flying relatively close to Earth this month, and so I'm going to get some imaging on it here and be able to solve for the orbit later on. The asteroid is this star right here. It's actually an asteroid, not a star. This is 1998 OR2, and don't mind these little dark circles, these are dust motes on the CCD. So yes, as Eric Briggs says in the chat, Comet Atlas is disintegrating. Wah wah wah, sad trombones. So we will be viewing what's left of Comet Atlas as it disintegrates tonight. That's going to be the main attraction. I just want to get a few minutes here on the asteroid so I can solve for the orbit later on. People are saying my audio is too low. Alright, hang on. Simple fix. How's this? Going to bring myself a little closer to the microphone. Alright. Yeah, we're gonna have to deal with OR2. There's conspiracy theorists making claims this asteroid's a threat to hit Earth, or just people who are concerned, legitimately concerned, that it could be some kind of threat. So, to head that off, I'm collecting some images of it tonight that will allow me to calculate the orbit of it, independent of NASA, independent of any space agency, really. You still can't hear me? I'm showing pretty good levels here on the microphone. Hang on a second. Yeah, audio's coming through very good on my end now. I've just listened to the playback and should be able to hear me just fine. So check your audio settings at this point, because I've amped up the microphone here quite a bit. Oh shoot, I missed it. I think the asteroid moved quite a bit there between the last image and the newest one. Alright, well, I'll watch for it for this next image, but it should be moving. This object right here. Somebody in the chat probably caught it if I didn't. I also don't know if my chat's actually up to date. No, it's not. Okay, audio's fine. Yeah, sometimes my chat freezes on my phone. I'm looking at my phone here trying to keep track of the chat, and sometimes it just freezes up, and I'm like, okay, nobody's saying anything. Another comet bites the dust. Yes, it's going the way of Comet Ison, Comet Elenin, and all these other disappointments. And I did try to warn you guys, I did. I was on with Francis Walsh a couple nights ago on his podcast, Collision Course, and because he had filmed a video that was starting to go viral showing what he thought was possibly a second object moving alongside Comet Atlas, and it looked to me like it was just a pair of stars, maybe a couple of the brightest stars near the comet, but not the comet itself. Not sure why the telescope wasn't tracking properly on that, but it looked like maybe the telescope had lost tracking a little bit or something. So anyway, I was on with him a couple nights ago on his podcast, and he asked me, very frankly, what I thought was going to happen, what my gut instinct was on this comet. And I told him I thought there was a better than not chance that it would disintegrate. And then, lo and behold, today the headlines on spaceweather.com read, Comet Atlas is disintegrating, sure enough. So I kind of had that feeling, especially after looking at the images from my last webcast. It didn't look like it was continuing to brighten, and it was actually plateauing off, according to the photometry. And now it's starting to dip, and the central condensation is going away. So there, a new image came in, and you can actually see this object is slightly elongated. It's not circular like these stars. See how the stars are just points of light, but this object is a little elongated there. That's because it is an asteroid and it is moving, even in the 2 minutes that it takes to do these relatively short images. So we'll collect a few more minutes on this asteroid here and then move on to the Comet Atlas, or what remains of it. Can you look for Pepe Colombo spacecraft when it comes back for its gravity assist on the 10th? Oh my goodness, I forgot about Pepe Colombo. Yes, I would love to. I gotta look up and see whether it's predicted to be visible from my area, of course. Depending on the timing of all of that, I don't know what time. Eric, if you have that information, can you let me know what time close approach is and all that stuff? UT's fine. I just want a general idea of when it might be closest to Earth. That would be awesome. That would be incredible if I could track Pepe Colombo. That should be Friday, right? The 10th, I think. I'm casting from Florida. This is all from Florida. Even if it's not visible from Florida, I could try to get on it with one of the eye telescopes, maybe in Siding Spring, Australia, or in Spain. Forget the location in Spain, but yeah, there, or even California, New Mexico. There's scopes all over the place on the eye telescope network, for which I am a scientific advisor, full disclosure. And astronomy is expensive, so much to buy, very true. With eye telescope, you can rent time on very powerful telescopes, even more powerful than this. But even that's, to be perfectly honest, it's not super cheap. The biggest scopes on that network can go for $300 an hour or more. So, yeah, it can be quite expensive. And I should also mention the music tonight is all brought to you by Stellar Drone, used with permission. Thank you to Stellar Drone. And the telescope is an 8-inch Meade LX200 Schmidt-Cassegrain, operating at f10 with an SBIG ST-2000XCM camera and an SBIG AO-7 adaptive optics unit, providing high-speed guiding, which is why these images look so good. These stars are nice and round, not getting guiding errors really. The other thing I did tonight when setting up, which I should have done a while ago, I've been slacking off on recollimating the telescope. So I recollimated it tonight. It should be in pretty darn good collimation. And I think it has improved the quality of the stars here. I think they look a little tighter and less optical distortions on them as a result of that. But this is an 8-inch LX200 Classic on a wedge, polar aligned. Not a super fancy mount, and the AO-7 really is what allows it to track with these long exposures for 2 minutes apiece without any guide errors, because it's correcting at 3 Hertz right now, 3 times a second. Oh, the clouds came in. Yeah, I'm a little scared of that too. It cleared up today. It was pretty cloudy throughout the day, but then it cleared up, and I do want to get on the Comet here pretty soon. But just wanted to get some quick images in on this first. Hey, Scott Mayer. Do we know what Comet Atlas is composed of? Well, It's not sugar, spice, and everything nice. It has volatile materials, probably ranging from cyanogen, molecular carbon, carbon monoxide, possibly to some extent, maybe some carbon dioxide, I don't know. Maybe some water ice, but there's a bunch of volatile ices, along with dust and probably some silicate material. But it's important to note that although it is we believe it is disintegrating, dissolving, fading out into nothing, whatever remains of it will continue along the same general orbit. Now, they have noticed non-gravitational forces. This has been one of the headlines. Non-gravitational forces have increased on this comet. What that probably means is that it's fracturing up into smaller pieces, and because those individual pieces have lower mass, they are more subject to the forces of solar wind, solar radiation pressure, and the outgassing from any residual ice that's left. Internal ices are now being exposed, and it's having its last gasp if it hasn't already. And so, with the increase in surface area as it breaks up, that accelerates the final outgassing process, and also gives a literal acceleration to the particles that remain in various directions. However, it's important to note, it's not coming anywhere near Earth. The change in velocity that would be required for it to be put on, any chunk of it to be put on an impact trajectory with Earth, is orders of magnitude, many orders of magnitude greater than what the comet could possibly impart, even if it exploded. Okay, let's say there was a big buildup of gas pressure and it suffered a massive explosion, kind of like Comet Holmes. Even if that happened, it still would not give it the kick it needed to send any significant chunks our way. We're talking about something here that, let's just ignore the gravity of the sun and the planets and everything for a moment. And knowing that it's going to pass us by towards the end of May, I believe, that's not a whole lot of time to cover a close approach distance of over 3/4 the distance to the sun. It would require a shift in its trajectory of roughly, I want to say 13, 14 kilometers per second, somewhere in that ballpark. That's a huge amount of velocity, okay? To put things in perspective, a fully fueled space shuttle sitting on the launch pad, ready to go, has a delta V, the ability to change its velocity, of a little more than 9 kilometers per second. It's got to get up to about 7, maybe a little more than 7 kilometers per second in orbit, and then some velocity is lost due to gravity losses on the way up, because Earth's gravity is trying to pull it back and all that. But the delta V on the space shuttle isn't enough. So if you had a fully fueled space shuttle sitting on this comet, ready to blast off, SRBs and everything, ready to launch itself towards Earth to try to hit Earth as it goes by, it really would not have enough fuel to do it. So there's no threat to Earth. I want to make that perfectly clear, and I'm going to do a video breaking that down in more detail later. But, okay, I think after perhaps this image, we'll have about 14 minutes of images of this asteroid. I think that'll be enough to collect some data for tonight, and we'll move on to the comet, the main attraction. Could eventually hit Earth in the coming millennia, couldn't it? I mean, generally speaking, the debris is going to diffuse out, but it will generally continue along that orbit. I mean, yeah, I guess anything's possible over thousands and thousands of years, but it's not really worth thinking about at that point. The odds of that would be strikingly low, I would think. And in any case, that's thousands of years in the future. By then, hopefully, we'll have the Starship Enterprise to defend Earth. Probably plenty of other things to worry about between now and then. Alright, that'll do it for this asteroid. So we've saved those images. I'm now going to change the file name. This will be Atlas. We'll call this 4. What are we at here? 7th? Yeah, 7th. Just gonna give it a slightly different name so it's easy to distinguish it from the other images I've taken over previous webcasts. We're not going to autosave right away. We're going to verify our pointing position first when we get there. So I've got to carefully move the telescope to the comet without colliding anything this time, right? We don't want another repeat of that last problem I had. So I'm going to get over to the scope now and get set up to move it to the comet. And I'll catch you on the other side. Okay, we should be close. Let's check out our situation here, and let's just do a 5-second 3x3 exposure. We're gonna reduce the resolution of these images, take them down to grayscale, increase sensitivity, and get a lay of the land, see where we're pointing. Ah, I see Comet. What's left of Comet. That's definitely a diffuse object down there. That looks like Comet Atlas. I was expecting to put it in the bottom, yes. Now, I was also expecting to have a guide star that is sufficiently bright. Very bright, actually. This will be Guide Star HD 51708. This will be fun. Let's see what we get. No, I don't see Guide Star. Oh, there it is. It's hiding over there. Okay. Alright, I'm happy with that, actually. I'm going to leave things right where they are. Actually, no. We can do much better than 0.3 seconds. We can do 0.1 seconds. Okay. High-speed guiding. I love it. Okay, now we can start saving images. We are on the Comet. We are on our guide star. The Comet should, over the course of the evening, move up and to the right in the frame, so it should be coming up this way through the view. That'll be nice. We're going to go to 1x1 binning. We're going to go to 2-minute exposures, same as we've done every previous webcast on this Comet. We're going to do apples to apples, right? I don't know why. I'm really excited about this. To find out what's left. Take pictures of the disintegration of this comet. I mean, I feel sad that it didn't live up to expectations, but I did say this thing could come apart. This thing could disintegrate. And I also tried to make clear, although I probably didn't emphasize it enough, that even if it disintegrates right now, I swear I've heard these words come out of my mouth before. Even if it disintegrates right now, it's not a threat to Earth. I said all that for a reason, you see. How long am I planning to stream? Hey, Dick, good to see you. Oh, I'm going to go a few hours at least. Should you be doing a beer run here? I mean, I should be still streaming when you get back from grabbing some beer. Be careful out there, man. Be safe. Lots of clouds and light pollution for you. Oh, IB Hunter. Sorry to hear that. And we got 200. We just hit 200 viewers on the stream. Awesome. Welcome, everybody. Hope you enjoy the stream. And before still whole. I mean, that would be great if it were still whole, because then maybe it could live up to expectations. Maybe it's having a second wind of power here. I don't know. I'm really not counting on that. I think it's probably going to be a goner. But like I've said, I mean, this is why I've been trying to do so many live streams on this whenever possible, because you just never know. You can't count on a comet to survive. You can't count on it. You can't take it for granted. You can't count on it being there later on. So you might as well get while the getting's good. But I would love for it to stay together. I would love for it to meet expectations. But I really don't think it will. Alright, let's see what we get. First image coming in. Oof. Oh, my friends, that is the remnants. That is the disintegrating remnants of Comet Atlas. You guys can go back. Anyone who hasn't seen it, go back. Look at one of my previous webcasts on this comet. Any of my previous recent videos. That is not what it looked like, is it? Just a few days ago. April 2nd, I believe, was my latest webcast on this comet. It looked a lot better than that. You could see a clear, bright spot at the tip of the comet where it was still outgassing. It was actively producing material. What you don't see now is a spot where it's actively producing material, really, or at least not strongly. You have what looks to me like an elongated pseudo-nucleus, and so this is the brightest spot on the comet. We usually call that the nucleus. And normally, it's a tight point, or at least somewhat. I mean, it's diffuse, but it comes to a circle, you know? It's not elongated like this. And this is not due to motion. Like I said, this is apples to apples. Same exposure length as all my previous webcasts on this comet. 2-minute exposures. And we are not seeing active... we're not really seeing much activity here. We're not seeing really strong production of dust and gas coming off this comet. Now, one of my previous webcasts on this comet was with the focal reducer, which basically took me down to 66% or 65% of the natural apparent magnification of this image, okay? But most of the other webcasts have all been at f10, the full focal length of the telescope, including this one. So again, I'm trying to keep things as apples to apples as possible. And you can see a very stark difference here between what the comet looked like back then versus what it looks like now. Okay, so here comes the dark frame. That's going to take out all these colorful hot pixels and cancels out the noise. And you can see now we're not seeing strong activity here. So I'm going to move the auto guider window if I can. I want to move this on down to keep an eye on the comet. Oh, come here. Hard to do this with the trackpad, touchpad on the laptop, especially one-handed. Okay, let me get more stable grip on things. My live streaming setup here is a two-computer solution. Okay, this way I can keep an eye on the old auto guider. Let's move this out of the way for a second. Move this over here. Move this down here. Okay, just repositioning everything to maximize our view of the interesting stuff. Okay. Cool. And there we go. So, now you can see the timer with the countdown of the images. These are going to be 2-minute exposures again, and auto guider tracking that star up there. And we're just going to watch as what is left of Comet Ice, or man, that's a Freudian slip, Comet Ice on Comet Atlas. What's left of Comet Atlas is going to move up and to the right in the view, gradually. Alright, well, looks like the reports of Atlas's demise are not exaggerated. But we will still see it moving through the image here. Here comes the next image. Yep. Quite a bump in its position, because it took an extra 2 minutes there to collect a dark frame. Now each image will be coming in every 2 minutes, so should be steady from here on. We got clear skies, relatively cool temperatures, enough I can get the camera down to -10 degrees Celsius for better noise profile. And we're just going to track this comet all we can and say farewell to what was Comet Atlas, or what remains of Comet Atlas. Yeah, just wait and see. Someone will be claiming it was heading towards Earth. Yeah, it definitely wasn't. In my previous video, I released some new open source software for measuring the coordinates of the comet, and also making time-lapse videos of the comet from the raw FITS files. So these images are being saved as raw binary files called FITS files. It's a standardized format in astronomy. Both amateur and professional observatories use it, even the Hubble. But it's not typically used by a lot of other programs out there, programs that would normally be handling raw files from SLR cameras, unless those programs are designed to do astronomy, right? And I really wanted a smooth, quick, easy, streamlined way to go from raw FITS files into a video, or into individual tone-mapped still frames. So HDR type processing, tone mapping the images down from 16 bits to 8 bits. And you could do it, but it was just too many steps and too much time. So I wanted a one-step process, and so I wrote a program in Python to do it. And with AstroPy and OpenCV, I was able to do that. And then also using AstroPy, collecting the coordinates of the comet. That's going to be interesting this time because we don't have a tight nucleus. So the astrometry is going to be really difficult for the program I designed to do, because it's designed to pick the brightest pixel and say, okay, that's the center of the nucleus. Well, here, there's a line of pixels that are pretty similar in brightness. So my guess is, when I try to collect the astrometry on this, the position it's going to pick is going to be somewhat random up and down this line, and that's going to produce a ton of noise in the data. So I may have to switch the program over from picking the brightest pixel to just picking the exact spot I click, and have to just be more careful about clicking very carefully where I want to say, okay, track this part of the nucleus, wherever this part of the line is, maybe the front of the line or the back of the line that is what is left of the nucleus here coming apart. Track that consistently, right? And I can do that. It's a pretty simple modification to make. It just takes more time to actually collect the images, and it's a little more of a pain, I guess. And again, this was not intended to go up against existing software packages that do this better. Astrometrica does that better, but Astrometrica takes more time to, get your images loaded in there and process the data. Again, I wanted quick, easy, simple. I could just bang this stuff out night after night if I wanted to, and not take a lot of time doing it. I don't have a huge amount of time to do this, especially when I'm trying to process images, work, and then when I'm done with work, get the telescope set up, collect more images, right? It's a pretty demanding schedule. So to make things easier on myself, I designed this program, and I tried to do it as simple as possible, even trading off a little bit of accuracy for simplicity and speed. But in this case, that's really going to bite me, because there's a line of pixels here of similar brightness. So again, I'm just going to have to go after it manually. Yep. Alright. You can also tell the comet in general is just dimmer. It's not the comet it once was. It may have peaked at roughly close to theoretical naked eye brightness, the brightness that you could theoretically see if you were a trained observer using averted vision from pristine dark skies, you know, around magnitude 7.5 maybe. But even some sites I've seen, it's like it didn't get above 8. So it was close, but no cigar. Definitely not something that put on a nice bright show for us, as we hoped, based on the early brightening. But I did say, I'm pretty sure I said in my previous webcasts, not to be all I told you so, but I'm pretty sure I did say at one point, you know, that can sometimes be a sign that the comet's having its last gasp. And interior ices are being exposed near the core, but then it just comes apart. And those interior ices may make it look like a nicer, better, bigger comet than it's really going to end up being. And it turns out to be a disappointment for everybody. So I'm not the comet I once was either, yeah. Is my AstroPi open source software too? Yes. Well, AstroPi is I don't know if it's technically open source. It's a software package for Python. It's a dependency. Okay, so you can use AstroPi to make your own software. It's just it's a toolkit. So you can get that it's a Python package. You can install it with Python package installer, and use it to make your own software. So I made my own program to do astrometry using AstroPi, but yeah, you have to install that to make my software run. It's a dependency for my software because it's a package for Python that I use. Technically, wouldn't there be more surface area equals bigger coma? Yes, that's kind of what I was getting at. That as it comes apart initially, as those deeper ices are exposed and there's more surface area exposed, it can make the comet look bigger. I mean, it does make the coma, the tail, all that can grow bigger temporarily. But it's like the last gasp, and then it fizzles out. And that, I think, is exactly what we saw with the pattern of behavior of this comet, where it initially was beating expectations and had this rapid brightening, and then now it's done. But this might be a fragment of a bigger comet that originally existed. The Great Comet of 1844, we think, was another, probably much better fragment of that original comet, because it was a great comet. It was visible to the naked eye in 1844, and its orbit is extremely similar to this comet. Again, if you go back to my previous video releasing my software for astrometry for measuring the position of this comet, I solved the orbit and showed it in Celestia compared to the comet of 1844. So you can go check that out. So the next steps from this, of course, I'll be collecting more astrometry here to put that into my orbit calculations. Again, this is why it's so nice that I've done these previous webcasts and collected all these images, because I have a large baseline of data from just my own observations to work with. So I can work off of my own observations here and combine it with the images I take tonight to show how it matches up with my own personal predictions for where the comet should be, how much it's been perturbed by non-gravitational forces from the final outgassing and the solar radiation pressure and solar wind as it blows smaller particles away. I mean, that's what forms the tails, the solar radiation pressure and solar wind. Those particles, those dust particles, are very light, and so they're easily affected by those smaller factors that don't affect the physical nucleus nearly as much. But now that the comet is disintegrating, what's left is smaller, lower in mass, and so it's more susceptible to those forces. So I can show how much that is, how much it's effectively changed in its trajectory. Was this the only comet atlas? No, definitely not. How does the nomenclature work? Great question. Great question. So this is the full name of this comet is C/2019Y4. The nomenclature works like this. C denotes the type of comet it is. If it were P, for example, that would be a periodic comet. If it were I, that would be an interstellar comet. And C denotes that it's a non-periodic comet, which really generally means it's a long-period comet. A comet that has a long orbit. You're not going to see it again in your lifetime type comet. Okay, 2019 is the year it was discovered, of course. Y is the half month that it was discovered. That is the latter half of December. And 4 is the sequence of discovery within that half of a month. So it is the fourth comet discovered in the latter half of December 2019. So it's a systematic name. Atlas is the name of the observatory, the telescope system that discovered it. And so that system is designed to be a warning system for asteroids. It is the, I should probably look it up again to get it exactly right, but I believe it is Asteroid, Terrestrial, let's see, Atlas. I'm going to botch this up, so I'm going to look it up here and cheat. Asteroid Terrestrial Impact Last Alert System, right? So some people were concerned about that. Last alert system. So this is an alert? No. There are multiple comet atlases. Anytime that system discovers a comet, it automatically inherits the name Atlas. I discovered a comet in 2016 using the Stereo spacecraft. Although I was the discoverer, because I was using an automated system, Stereo, and I was basically panning through their images, analyzing their images to find the comet. They hadn't noticed it. I found it, but because I was using Stereo, the comet's name is actually Stereo. It's not my name. So it's P2016J3 Stereo. Likewise, if I were somebody sitting in the observatory over at Atlas and I was looking through the nightly images and I saw, found the comet, it wouldn't go after my name. It would actually inherit the name of the observatory, Atlas, because it's an automated system collecting images. Okay? So, hope all that makes sense. There are other comet atlases above, well, I don't know if they're above the horizon, but they're out there right now. C/2019Y1 Atlas, so the first comet discovered in the latter half of December 2019, was also discovered by Atlas. And that is actually above the horizon, but it's a much dimmer comet. It's a 13.9 magnitude comet in Cassiopeia, according to SkySafari Pro. Comet C/2019N1 Atlas, also above horizon. Magnitude 15.3, even dimmer comet in the constellation Draco. And then it looks like there was a shared discovery in C/2019F1 Atlas-Africano. So, looks like there may have been a shared discovery there. Another example of that would be Shoemaker-Levy 9, which hit Jupiter, or Hale-Bopp. These hyphenated names generally, it's generally because it's a shared discovery. And usually that means that, two independent observatories, two independent telescopes found it at the same time, and both submitted their discovery, and so you end up with a hyphenated name for the comet. That irritated, this is stupid trivia, but back in the 90s there was a movie called Deep Impact, and in the movie they try to do a realistic depiction of a comet being discovered that ends up hitting Earth and causing devastation and all the rest. And the comet in the movie is named Wolf-Biedermann. And it's a silly scenario that plays out near the beginning of the movie. Spoiler alert, one of the astronomers dies. Okay, so this kid discovers it at a star party, sends his photos off to a professional astronomer, who then confirms, yeah, it's there. And then that guy ends up dying in a car accident, but the disc is found by the government, and they cover it up and all that for a while. But they end up naming it Wolf-Biedermann. Well, that's not usually how that would work, because the professional observer was just confirming a discovery that the kid made. He didn't independently discover it. He shouldn't get credit. But You know, I guess you could argue about that. Say, well, maybe they would make an exception because he died, and this is a really important. I don't know, but that's not how the convention's supposed to work. And so there were some people I heard, other amateur astronomers, who were irritated by that inaccuracy. No problem, Joseph. I hope that cleared up some confusion about it. Another source of confusion for some people is the fact that comets and asteroids have two slightly different naming conventions, okay? So an asteroid like 1998 OR2, as you might have guessed, was discovered in the year 1998. And OR2, again, has to do with the time of the year it was discovered and also the sequence of the year it was discovered. But there's no C height, slash or anything at the front because it's an asteroid. And it also is not automatically named for the discoverer, unlike comets. So whatever system discovered 1998 OR2, or for an amateur, professional, observer, individual discovered it, doesn't matter. It's not automatically named for them. The discoverer usually gets dibs on suggesting a name once it's a numbered asteroid. And actually, that asteroid is numbered. It has just a number that is a sequential number handed out to asteroids once they are well observed. And I forget the exact rules on it, but they have to be observed for a period of time, which allows them to really nail down the orbit. If the orbit's still uncertain, you're generally not going to get a number assigned to an asteroid. And you'll never get a name assigned to an asteroid, generally speaking, until it's already received a number. So the orbit has to be pretty well known in order to receive a name. That's not to say there can't be any residual uncertainty in its future fate. Apophis is an example of an asteroid that has a name, an official name, and yet, there's still some uncertainty there, whether maybe, outside chance, one day maybe it'll collide with Earth, right? And it had that name while we were still working out that. I think it's pretty well established it's not going to hit us immediately, but, maybe one day in the future. So, but still, it was observed over a good period of time before it received a number and then an official name. And it can also be that you have prediscovery images. There's another little caveat. This can trip people up, although I think most people don't dig deep enough for this to trip them up. But let's say you find 1998 OR2, and you go and you look up the observations for it, okay? You look up the astrometric data for where, the coordinates that various observatories have seen this asteroid at, okay? You might find that there are observations of the asteroid that predate its discovery. Even though it was clearly discovered in 1998, there could be observations, not necessarily, but there could be, that are earlier than 1998. And you might say, well, what the heck? Did they cover it up? Did they hide it? No, not necessarily. And actually, yes, 1998 OR2 is a perfect example of this. There are the two first observations were taken the same night, June 30th, 1987, from the Siding Spring Observatory in Australia. So it was observed, 11 years before it was discovered. How can that be? Well, there can be pre-discovery observations. There could be observations where the asteroid was found in old images, but it hadn't either been noticed. Nobody noticed it was in those images. But once the approximate orbit was established, they can extrapolate that backwards in time and say, okay, here's where it had been in the past. Do we have any pictures that were taken at major observatories of these coordinates at these moments in time? And so doing a database search, they can find any photographic plates. Generally speaking, like in the 80s, it probably would have been a photographic plate that was taken, not a digital image necessarily, though they would probably scan that image. In fact, it even says DSS. That's probably Digitized Sky Survey, I'm guessing. The southern counterpart to the Digitized Sky Survey. I bet it's in those images. And so they will look at those images and say, okay, can we find the asteroid? Is it bright enough to have been seen in these old images where it should have been? And sure enough, in this case, they found 2 coordinates. Now, that might have actually been from a single image. That could be actually a single photograph, and they marked the coordinates for the beginning and the end of the image. Okay, the asteroid was here at the beginning, and it was here at the end. It could have been a streak, right? So that might have been a single photograph. But nevertheless, they had an observation of it from 1987, and it wasn't discovered then. Even if someone had noticed it, in 1987, that doesn't mean it would have been discovered necessarily if they couldn't find it again, okay? If you have a single photograph and it's a streak and it's moving at a certain speed, well, if the orbit is even slightly elliptical, that speed will change over time. And if it took you a while to even notice it, you know, you had to go get back in the day, you had to get the film developed, right? The photographic plate especially, get that developed, and then look at the negative and see if anything's moving. And then try to get on it again, maybe at a later night. Well, if you can't find it again, sorry, you don't get to count as the person who discovered it, because you didn't collect enough observations to make a prediction, an accurate enough prediction to track it again and keep up with it. So if you don't get to do that, then you really didn't discover it. You could also have cases where the asteroid had another identity, multiple identities, where it was discovered, then lost, then discovered again. So you can have lost asteroids whose orbits are too uncertain and you can't find them. And then later on, you might accidentally stumble across it again. And so sometimes on the Minor Planet Center site, you'll see, asteroid 1975 OR1 equals asteroid 1986 LR2, whatever. I don't know. Just making up designations here. But you might have an equal sign between 2 designations because they're actually the same object. It was discovered, lost, and then discovered again and given a new designation before they realized, oh, that's actually the same asteroid from years ago. It's over here. And then they'll link those objects and they'll have multiple identities. So that's probably too lengthy detail on how asteroid and comet discovery work. So apparently I had another question on which comet I discovered. I discovered Comet P2016J3. So I discovered it 4 years ago in 2016, and I used the stereo heliospheric imager pictures to discover it. This was not discovered on the coronagraph, actually. There are plenty of sun-grazing comets that are discovered on the coronagraph images that look at the sun all the time. There's constantly these little sun-grazing comets, and they, generally speaking, get vaporized by the sun quite often. And so those are discovered all the time, but they usually don't get formal designations from the Minor Planet Center. This one did, in part because it was discovered not using the coronagraph, but the camera looking sideways on the spacecraft, okay, out the side, not towards the sun. And so that's unusual. That means it was a more significant comet, probably, than most of the sun grazers. Still it was not a huge comet or anything. It was pretty minor. You wouldn't have noticed it. There was one amateur in Colorado who observed it a month or 2 after I discovered it, but that was about it. It was a periodic comet in a relatively short period orbit, but it was not well positioned for viewing from Earth. In fact, at the time I discovered it, it was not possible to see it from Earth because stereo was basically on the opposite side of the sun from Earth. Again, this was 4 years ago. Stereo ahead has sort of gone around behind the sun and is now catching up to us. But 4 years ago, it was further back, kind of behind the sun, not directly, but basically the comet was not observable from Earth at that time, not till about a month or 2 later, and the comet was observed briefly by an amateur in Colorado. The image is up on aerith.net. So yeah, I did actually get to discover a comet, though not with my own telescope. You turned the sound off because you hadn't seen that movie yet. Oh. Lame movie, but seeing it, it's the end and all. Yeah. I back in the day when I first watched it, I appreciated it more than Armageddon because it felt like at least they tried to get the science closer to correct than they did with Armageddon, which was just, schlock. It was just action film. Actually, I think it was Chris Hadfield did a video recently on The Verge or something where he was talking about some of his least favorite space movies, or some of his favorite space movies, I guess, just his general experience of watching space movies. And, just like me, when I watch a space movie like that, sometimes it'll irritate me if it depicts things wrong. And I was so glad to see him rip the movie Gravity. So many people love that movie, and I get it. The visuals are beautiful, and he, agreed on that. But the way they depict astronauts is so off the mark. They, in trying to depict the excitement of being in space, they show an astronaut before the movie really kicks off, before the things really start going south for the astronauts. They show one of them bouncing around on his tether, throwing himself to sort of bungee jump on his tether in space in the payload bay of the space shuttle. I'm sorry, no astronaut's going to do that while you yelling, "Woohoo!" Nobody does this. Nobody does that. And you're not going to have a situation where your commander or whoever is leading the spacewalk is just getting to know one of the other spacewalkers while they're spacewalking. Like they've never met before. That's not how crews work. And I was so glad to see him say all those things, because those were things I thought coming away from that movie. And I know my dad watched it with me. He hated it too. So if he's watching, there's a video now from Chris Hadfield giving the criticisms on that movie. But yeah, he also critiqued Armageddon, this Bruce Willis action film from the 90s. And he it was fun to watch him tear it to bits. It was a bit like watching, Neil deGrasse Tyson give a breakdown of everything wrong with the science of a movie, but from the perspective of an actual astronaut, And I was glad to see, again, he kind of agreed with my opinion of it in terms of The Martian was probably the best movie I've ever seen for how it depicted the personality of an astronaut, just from having, met a few astronauts here and there. These are very professional, very intelligent people, very determined and innovative. And if you had an astronaut stranded on Mars like that, he would act probably a lot like Mark Watney. The way that's depicted is professional but with a fun side, but also very resourceful, right? And probably the best depiction of that personality type that I've seen. And that was Chris Hadfield's impression of that as well. So anyway, go check out that video. I don't even think I've seen the whole thing. It's pretty lengthy. Sit down with Chris Hadfield on his thoughts on various Hollywood movies. Alright, so enough Hollywood. We've got a real comet on our hands here, or the remains of one. So yeah, as it comes up in the view here, there's almost like a little bit of a bright spot here, but it's not quite point-like. It's slightly elongated. And I think it helps that I'm imaging here at the full 2-meter focal length of the telescope here. This is pretty high magnification view. So it allows us to see, any slight lengthening of the nucleus, because each pixel here is corresponding to, I think it's a little less than an arc second, actually. It's pretty small field of view and a pretty small image scale. So you're looking here pretty close up at this comet for a telescope this size. Oh, when did the video with Chris Hadfield come out? I don't know. That was a few weeks ago, I think. Wasn't too long ago. Man, the bugs. Something was real attracted. Something real big, a moth of some sort, was real attracted to one of my monitors there just now. Came buzzing in. Yeah, POFIS got up to 2.7% chance it would hit the Earth on April 13th, 2029. Thanks for looking that up. Yeah, the 2029 impact, I think, was the first one ruled out. I mean, it was also the highest chance that came up. But then there was a chance that, although it might not hit us, it might pass through a gravitational keyhole that allows it to then come back and hit us 2036, I think it was. And even that has pretty much been ruled out at this point, I think. But there still remains more work to do there, because projecting out 16 years on an asteroid like that is not super easy. You really need high, precision measurements. And unfortunately, with asteroids like that, near-Earth asteroids, even relatively large, I mean, that's not a huge one, but it's, good size to cause some damage. it really can't be seen unless it's relatively close to Earth. So you can't just view it in a given night. You got to wait for an opportunity, and sometimes those opportunities can take a while, over a year, to come up. And that's really the trick with trying to rule out asteroid impacts and detect them. So yeah, it does look like there's a thin, slightly brighter line of the comet here, where my cursor is. And it kind of does, I mean, it does look a little brighter there, but it's also looking elongated. I can try to zoom in on this. Yeah, there we go. That's better. So I hope you guys can see what I'm talking about. You know, there's a few pixels along here that may be slightly brighter than the other, surrounding diffuse cloudiness to it. And it strikes me that maybe that's, you know, the elongated, as they call it, I think, the astronomical telegram that I posted a link to on Twitter. I think that called it a pseudo-nucleus. Let me see if I can find that link and throw it in the chat. I had it up on my Twitter. Alright, I'm just gonna throw this in the live chat here for you guys. Yeah. So it says here within the telegram, images taken on UT 2020 April 5th, 5.6 to 5.9 showed, so that's fractional day, by the way, showed an elongated pseudo-nucleus measuring about 3 arcseconds in length and aligned with the axis of the tail, a morphology consistent with a sudden decline or cessation of dust production, as would be expected from a major disruption of the nucleus. And all that is fancy speak for the thing is falling apart. Let's see how it looks on this next image. So, yeah, again, kind of looks like we have an elongated, slightly brighter part of it here, maybe. Hard to say, but definitely this comet, if you compare it to my previous webcast, this is not what it looked like. There was a defined, brighter region at the tip. You know, somewhat oval, but definitely a defined, brighter portion. And it was just overall better looking than this as a comet goes. Whereas here we don't have a real strong nucleus. We don't have a really strong central region of condensation, of dust and gas production. So this is why I say I think we really are looking at the disintegration of this comet tonight. How wide in arcseconds is the visual of the comet? That's a great question. Let me tell you what, I don't have the ability to, while it's collecting images, I don't have the ability to pull up other windows on the imaging computer, and I'm not actually saving these images to a shared directory with my broadcast computer, unfortunately. But, good news, I do have the astrometry from my previous webcast. And that was taken at f10. So I'm just going to upload that, because the astrometry, in terms of the angular size here, will be the same. So I'm going to tell you guys what the pixel scale is. Keep in mind, of course, we are magnified beyond the 1-to-1 size of these images. I'm zooming in here on individual pixels. You can see how pixelated these stars look. And you can see like some of these little squares where there's color at the edge of the star. So that's your pixel size, okay? So when I say each pixel corresponds to a certain angular size, keep in mind that's the size I'm talking about, the size of these individual pixels on these stars, okay? So with that said, I'm kind of silly here. I'm uploading an old image of Atlas from a previous webcast so I can get an idea of what the exact image scale is. Yeah, and here in this image, it's just It's like just a general cloud of debris. It's not like there's a real central bright spot. So it'll be interesting to see what happens when I stack the images. Does a central, slightly brighter, elongated region really come out? Is it sharp? Or is it, diffuse? Really diffuse? I'm really glad we got an early start here tonight. I was originally planning for a start time of 10 o'clock right about now, but setup went very smooth. I think Venus was actually a help with that. I was able to get the telescope focused on Venus, so I could easily see the North Star through the eyepiece even before it got dark. Roughly what velocity is this traveling at? I'll tell you in just a second. So here we go. The pixel scale is 0.753 arcseconds per pixel. So every pixel here is 3/4 of an arcsecond, less than 1 arcsecond in length. So yeah, if they're talking about the nucleus elongating to 3 arcseconds or so, that should be detectable in these images as a slight elongation of the nucleus. And I think that is what we're generally seeing here. Now, as for the speed, let me pull up that data. And you can actually find this on my previous video where I solved the orbit of the comet and generated an ephemeris of it. In the directory of the Google Drive I included as a link in that video description, if you go to the text file ephemeris or ephemeri.txt, you can get columns at the end. There are vel and svel, the radial and lateral velocity of this comet relative to Earth. So right now, on the 7th of April, the comet, according to my calculations, is at a radial velocity approaching Earth of 5.6 kilometers per second and a lateral velocity going by Earth of 20.3 kilometers per second. So again, this new image here, you can see it's like a little diagonal streak of brighter pixels there. I really do hope that comes out in stacking as a, sort of a slightly brighter portion that I can see in the stacked image. We'll see how that comes out in the end. So yeah, there's your velocity, 5.6 kilometers per second towards Earth and 20.3 kilometers per second laterally. Now, it will pass by Earth safely at a distance of 0.78 astronomical units, and at that time, it will peak out somewhere around 50 kilometers per second, maybe a little higher, in lateral velocity. It's going to accelerate, of course, as it approaches the Sun. And also, it also depends on how its velocity lines up with Earth's orbital velocity, right? If it were heading away from us and our orbit carried us towards its general direction, that's going to lower the apparent velocity radially, for example. But yeah, with all that said, it's going to peak out even higher velocity than that on the way out as it speeds away from us. And as we round the Sun, it's vector addition, right? It's like we're adding our orbital velocity onto that radial velocity because it's moving away from us and we're moving away from it as we round around the Sun later on into the summer. How do I polar align the fork? That's a great question. The answer is with a wedge. I've got the Meade standard equatorial wedge. Not a very fancy wedge. This is no super wedge. This is definitely not a custom. Who made that? Malin? I forget who made that. There were custom wedges made by independent third parties as well that were even higher quality. This is the basic of basic wedges to polar align the fork arms. So it props the telescope up diagonally so that the fork arms point towards the North Celestial Pole. And I did iterative polar alignment today. It's just a faster way of doing things when you're trying to get set up quickly, like I was tonight. So the iterative method works by slewing the telescope. First you got to get the telescope set up on the wedge and everything. Physically position it so it's in the home position. So when you power it up, it should be pointing at the celestial equator, at 0 degrees declination, and at the meridian. Then you execute a go-to command. You tell it, move to where you expect Polaris to be. So it slews to Polaris. Then you physically move the mount, the wedge, so that you get Polaris in the view. So you have to find Polaris by physically moving the telescope to get it in the view, get it centered in the view. Now, in a perfect world, if you had perfectly homed the position of the telescope and the telescope were perfectly level when you started it up, if all of that was true, you would be perfectly polar aligned at this point. Also, if your go-to command was perfectly accurate. But none of that is actually true. So you do iterative steps where you slew then to a star far from Polaris, preferably close to the celestial equator, and at least a good 45-90 degrees from Polaris in right ascension, and tell the telescope's computer you're now centered on that star. So you find it with the motors and you center it and you sync the telescope's computer on that star. Then you bounce back to Polaris and move them out to get to take out half of the error. So Polaris will now be off-centered a bit. Then you move them out again to get it closer to center, bounce back to the star that you had previously aligned the computer on, realign the computer, bounce back to Polaris, take out half the error. You keep doing this over and over to reduce the error. Now, I only did one iteration, 2 iterations. It wasn't much. I did a very quick align. You very quickly converge on a solution that's pretty close, close enough for this kind of stuff. I'm not taking hour-long exposures here and hoping for, absolutely no field rotation. But I do want, say, no more than a tenth of a degree or so per hour. I don't want the field to appear to be rotating over the course of an hour, right? So I want to get most of that polar alignment error out. And really, within an iteration or two, you're already generally, if you do it right, you should be converging pretty close on a solution. So that's how I do it, because it's a lot. If you do it like that, it's not as accurate as a drift align for sure, but it's fast. It is very fast, and it's hard to argue with fast, especially when you're trying to do a live webcast. So that's what I did. If the nucleus were to break into 3, at what point would it be considered 3 comets? That's a great question. Well, those nuclei would have to still be active and producing their own coma and tail. And then, yeah, you could get A, B, and C subcomets. There are examples of that. But I don't think that's what we're seeing here. That could change. That'd be cool if it did, if we ended up getting separate subcomets, but I don't really see a strong indication of that happening. I don't, in the pictures I've seen of that happening, like you'll see a tight nucleus here and a tight nucleus there. You'll see 2 or more nuclei with their own coma and tail. A perfect example of that was Shoemaker-Levy 9 before it hit Jupiter. It was a string of pearls. It was a string of comets, and each one had its own little coma and tail going on. Corey Caserta, can you take the difference of stacking images to coax out comet pieces from the pseudonucleus cloud haze? We'll see. That would be cool. Maybe we'll get a hint of distinct nuclei from stacking the images based on the orbital elements. That's what I've done, right? So I've created software to stack the images based on the predicted positions, the predicted motion based on orbital elements. So I'm definitely going to do the same thing here again. The nice thing about that, okay, well, there's a bit of a pro and a con there. The con is that if the orbital elements are not perfect, and they never are, there's always a little uncertainty there, you are throwing that into the stack, right? But you're not biasing it. You're not biasing the stack to where you think, okay, I think this is the same point I clicked on the comet before, so I'm going to click here. You could produce artifacts in your head that then come out in the image if you're not careful. If you're manually aligning on the comet, saying, okay, I think this is the same point as before, you might create like a photographic double image if you accidentally click on the wrong part of the comet, especially when it's diffuse like this and there's not really a solid point to lock onto in each individual image. So the cool thing about being able to align based on the orbital elements using my software is that you're not biasing it on any human factors like that. So we'll see what happens. I think that'd be cool. I'm not holding my breath on being able to do that, but that would be really cool. Had a fork mount for my C8. It's now on the Exos 2 mount. It has a polar scope. I see. Yeah, I don't have a polar scope or anything. Fortunately, my lot for my house is aligned true north, and so I actually used a line in the driveway, separation between the driveway blocks that goes north-south, and I just roughly aligned the mount on that as a starting point. It gets me pretty close, actually. It was not far off from getting Polaris in the view there tonight. So it's an easy way to do it. Not everyone can do it that way, it just depends on your situation, but with the house like I've got, and with it being aligned due north, with that line going due north-south, it's just a really easy way to get things going quickly. Sorry, that was too loud. There. A little background music, but I don't want it just coming in the microphone from the speakers. It's kind of a low quality way of doing that, so we'll fix that. Alright. When is it going to hit Earth? Never. It's going to miss the Earth by more than 3/4 the distance to the Sun, about 0.78 astronomical units. The debris from this is going to continue along in the general orbit, which is how I found it tonight, because I found it tonight based on the orbital elements, and as you saw, it was right where I expected it to be, at the bottom of the image. I deliberately positioned it that way so that it would come up through the image over the course of the evening of imaging. So yeah, it's not going to hit Earth. There's no risk of that, even with this breakup, even with the fragmentation, disintegration, whatever you want to call it, whatever it is. It's just not possible for the fragments to come towards Earth and actually hit us. It's missing by such a wide margin that you couldn't even hit Earth if you had a rocket ship and you blasted off in the comet right now. It's moving so fast through the solar system, you'd swing by Earth. You'd go by Earth before you could catch it, right? So it's just not a risk. Looks like it's changed a few reflective vectors, a little diffuse. Yeah, and I'm not sure if we're not. This is a background star here. I forget. I should have paid attention earlier. That there might be another one over here somewhere. But this is definitely a. I remember that one. That was a background star. That might be part of the nucleus there. I'm not sure. We'll keep tracking it and see what happens. Why do I have to crush your dreams like that? Some people are legitimately concerned about this thing, and I'm hoping to head that off tonight. That's part of the reason I'm excited for these images tonight, is to be able to, be one of the first on YouTube to bring these images to you and really tell you what's going on for real. Because there's a lot of snake oil salesmen out there who would very much like to sell you on fear. I mean, it's a sad truth, it's a sad reality, but if I were not an ethical person, if I were lying to you and telling you, I have proof it's gonna hit Earth, and look at me, I'm taking these images, and trust me, I've got the proof here, it's gonna hit Earth. If I were doing that, I'd have 10 times the viewers. People would be worried about it. People would be excited, in a negative way, excited about it. And so, that's just the sad reality. There's a lot of people who profit off of that on YouTube, just from the ad revenue alone, not to mention any sales they make on sponsors from survival supplies or whatever. There are other things to worry about in the world right now, as we all know. Bigger issues. This is not one of them. Why don't I have a permanent pier? Why don't I have a permanent pier? Well, for one thing, I just haven't had the money yet to build my own permanent observatory on the yard. But even if I did, I'm not sure where I'd put it. I kind of have to reposition the scope based on what I plan to observe. I got trees all around me, so I can shift the scope one way and have a nice clear view of the north, which is where this comet's hanging out. Or I can shift the scope the other way and have a much better view of the south. Still not great. The trees to the south are actually pretty tall, but I could get much better views of Orion and stuff. Where I'm positioned right now, basically couldn't see Orion until it's setting. So, great for the north, terrible for the south. And plus it's in the driveway, so I'm definitely not putting a pier in my driveway. So, yeah, it's that's the one downside to this lot. But, man, I do love the feeling of being surrounded by nature on all sides. Trees everywhere. Love it. Can't argue with the view of this lot, but leaves a little bit to be desired for astronomy. But it's also far from the nearest cities, that far enough that you get some decent dark views when there isn't a practically full moon out, which there is tonight. So the sky's plenty bright from the moon. But we're not viewing close to the moon right now. This dimness of this comet, that's not due to that. I mean, we had a moon during the last webcast I did that was probably in some ways more of a factor, even though it was not as full of a moon. It was closer, I think, in angular distance from the comet. So, that was a factor there too, and it wasn't this dim. In France, they had to, I'm not even going to say that word, demonetized, but, wow, who would have thought that would be a cure in the first place? I don't know. Texas time lapse. I don't see it. Oh, here we go. Will Earth pass through its debris field, giving us cool annual meteor showers? Great question, and unfortunately the answer is no. The minimum orbit intersect distance is the most important factor to determining whether that's a possibility or not, or whether that's just going to happen. The period of the comet is also another factor, I believe. If you've got a really long period comet, it's not going to frequently replenish the meteor stream. So although it might be a really cool comet, it may not give you as good a meteor stream as a periodic comet that's constantly replenishing its meteor streams. Okay, shorter period comets coming through, hitting perihelion on a regular basis every, few decades, are going to be better at replenishing meteor streams than a comet that only comes through once every, X number of thousand years. This comet, however, the minimum orbit intersect distance, that tells you how close does its orbit get to our orbit. In this case, it's more than half the distance to the sun. It's, let me look at my orbital solution again, as a matter of fact. I'll tell you. Not this computer. This computer. Sorry, wrong computer. This computer. Okay, let's look at the orbital elements that I calculated for this thing. I calculated a MOID of 0.6325. That was the minimum orbit intersect distance from my own calculations and observations of the comet. If you look at comets that do give us meteor showers, Comet Halley, for example, gives us the Orionids. That is a minimum orbit intersect distance that is 1/10 of that distance, 0.06 thereabouts, from its latest pass through the solar system. So that's a lot closer to our orbit, and that can and does produce meteor streams that we run into every year. But to do that, that orbit has to intersect with our orbit, and it does not in this case. And I've heard, stories about a comet that was first seen, I believe, in the 18th century, and then finally identified as a periodic comet in the 19th century, which is Comet Biela, something like that. That's definitely a German name. Wilhelm von Biela. I believe that would have been pronounced Bela. It was observed to split up and hasn't been seen since the 19th century. But its remnants do produce a meteor shower, the Andromedids. So there's an example of a comet that disintegrated, we think, or at least it fragmented and then disappeared, so it probably effectively disintegrated or it went dormant. And we do run into its debris. We do run into its meteor streams every year, and that produces the Andromedids. But if you look up the orbit of that comet, you type in BIELA JPL SSD for the Solar System Dynamics page, or the small body browser. Go there, look up the moid of that guy. So that comet has, and again, this is working off of relatively old observations, very old observations, 19th century. But they did have a way of measuring the coordinates of the comet over time, and so we can calculate the orbit off those observations. It has a minimum orbit intersect distance of 0.0005 astronomical units. Okay, much closer. It basically runs straight into our orbit. So it did leave behind debris that we run into on an annual basis and produce the Andromedids. So yeah, that's how meteor showers are generally produced. Most of them come from comets. And even if a comet doesn't disintegrate, like Halley's Comet, for example, it's still intact, but we do get meteor showers from it. Those meteors are left behind along the orbit of the comet. They tend to spread out over the orbit of the comet. The really light dust gets blown back into the tail, but that stuff generally keeps moving with the comet. I mean, it doesn't linger around. It gets blown away by the solar wind, solar radiation pressure. The pebbles, the little tiny grains of sand that burn up in our atmosphere that produce meteors, are a little bit weightier than that in most cases. And so those have enough mass that they tend to linger around in the orbit of the comet that originated them, which is why the orbit has to intersect with our orbit to produce the meteor shower. So even if this comet's tail were to persist long enough to brush through our orbit on its way through our ecliptic plane, it would not leave us a meteor shower that we would get to experience. Okay, and we're not going to be there at the point where that tail is pointing when it crosses the ecliptic plane. Mars will. Mars would be getting pointed at by the tail, but obviously this comet's kind of done. As far as we can tell, it's probably on a downward trend from here on out. So even at its best, it was not a tail that was long enough to reach out to Mars from what people have seen in pictures. Generally, wide field pictures showed the full length of this tail better. Here we're still zoomed in tonight, and that's fine. That's my decision. I didn't want to put the camera on the refractor for a number of reasons. One of which is I really wanted to see what's really going on with that nucleus, and also make these images, apples to apples with the previous observations of the comet. So that's what I've done here tonight, and I think it's been worthwhile to do it that way. Beeloo. That's an inside joke at this point. I love it, though. Beeloo. Oh, yeah. That hoax. What was the deal with... Was Beeloo predicting a comet to hit Earth at one point? I don't know. Well, that was the... They called it the convex Earth conspiracy. It was like a... Or was it a... No, it wasn't concave Earth. It was like a convex Earth, they called it. But the it was like a flat Earth type thing, but it was a joke. And if you look at like the logo for it, for those who don't know, this Beeloo thing, this claimed to be this alien hiding in a bush telling people the real shape of the Earth. And they produced this picture, and it's like a 3D model of like a toilet bowl with a tank taken off of it and filled with the continents and the oceans and stuff inside the toilet bowl. That's what it looks like. And some of the flat earthers like bought into it, but it's like they hadn't seen the whole video. And the originating thing, it was the laser test. All right, they claimed to do a laser test showing Earth's flat, even though they're calling it the convex Earth thing. But it all got started with this video of them talking to an alien who was supposedly hiding in a bush, who had an accent that made him sound like the character Elmo from Sesame Street. It was the funniest thing I've seen. It was so funny. Go check it out if you have it. It's probably still somewhere on YouTube. Beeloo. Sean Hufford and some others were cracking up at it at one point. Sorry, I just saw Mark's comment about Beeloo. That was a good time. That was good memories. Oh. I guess Beeloo sounds like the Bela comet. Yeah, it's very similar spelling too. Yeah. Just substitute a few letters and you have the alien Beeloo, I guess. Texas time lapse. That's the first comet I haven't kept up with. I had to move back to the big bright city and no access to my dark sky side. Oh, sorry to hear that, man. That stinks. I've been there and I've experienced that pain. Our little comet, or what remains of it anyway, is moving up now towards the center of the image. I apologize. I'm going to zoom out for a moment and just get a view of what's going on here. Trying to make sure everything is staying in focus with the stars. Looks good. Just surveying the stars, making sure I don't see any hint of focus issues. Okay. Oh, where did I put the comet? I must have zoomed in too much. Okay. Silly me. There it is. Okay, let's zoom in that direction on the image. Oh no, too much. Didn't mean to click it again. Okay. Zoom out, zoom back in on the comet, and not click too many times this time. Okay, there we go. That's better. You know what Bob Ross says. There's no accidents, only happy little accidents, right? Dallas, Fort Worth. Telescopes never drag out anymore. Yeah, that's the disappointing thing about being in a really light polluted area. It saps your desire to go outside with the telescope and set it all up, doesn't it? And I was in that boat for the longest time. I was having to drive out to an island to get away from city lights near where I was working. Now I've moved out to a darker area. Got my own property here where I can just set up and enjoy without having to drive the equipment anywhere, which is really nice. Also being able to plug into house power, not run off batteries all night. Really nice. Though those lithium batteries I run on for the launches still, they're quite good, but man, it's a lot easier to manage when you can just plug everything in. No mistakes, just happy accidents. That's it. That's the quote I was looking for. Thank you, Andrew. Let's keep an eye on the auto guider. So for those who might have joined late, the dark circles that you see around are generally dust motes. These might be dead pixels or hot pixels that were like completely hot and then subtracted. But usually if you see a dark circle, like there's a huge dark circle here, this is probably dust on the quartz window that leads to the CCD chamber, away from the CCD a bit. The bigger the dark circle, generally the further from the sensor it is. And it's a donut shape usually because of the shape of the mirror of the telescope. It's a kind of a donut shaped mirror. It's got a hole in the middle that the light passes through to get to the imager. And so really out of focus things take on the shape of the mirror. And for those who want to know, C2019Y4 Atlas here that we're tracking is in the constellation Camelopardalis. That's a tongue twister, isn't it? Right ascension at the equinox of date is currently 7 hours, 6 minutes, 46.84 seconds. Declination positive 6734.27. Believe that's... Nope, that's not current. Okay, let me do that again. It is in Camelopardalis, but the coordinates at the moment, not hours from now, the coordinates at the moment are predicted to be 7 hours, 8 minutes, 32.28 seconds, positive 67 degrees, 37 arc minutes, 48.3 arc seconds in declination. And of course those coordinates are changing as the comet moves, which we're observing here. But you can go to heavens-above.com and get a finder chart if you want to look for this comet while you still can. Look for it while you can. It is fading. I've heard one person say that they couldn't see it with their 5-inch telescope, and another person, I don't think it was the same person coming back, somebody else saying it was a faint smudge in their 5-inch telescope. So you probably, well, you might start to need a telescope to see you got the moonlight to deal with. But maybe with good quality large binoculars, you might be able to spot it as a faint smudge as well. I'm not sure. Depends on how much it's dimmed already. But with a small amateur telescope, you should be able to see it. It's also probably going to depend on how much light pollution you're dealing with. If you're in a major city, you know, you can probably be expected to face more resistance trying to find it. So I'm going to post a finder chart here from heavensabove.com. It's a good site to check out for getting satellite satellite predictions of when satellites are going to be overhead and visible. The end is coming next Friday. I'll be sure to clear my calendar. No, I don't think so. According to Dr. Claudia Albers, the end was supposed to come like a couple days ago, and then the next day, and then the next day, and now it's like the next couple days. Yeah, she keeps moving the date. Oh, you got Reds joining for Atlas Night on the Shills as well? You're having a Comet Atlas Night on the Shills? Oh, you mean for the debunking? Oh, yes, yes. Well, and hey, yeah, that's a good point. This, the data I'm collecting tonight might be useful for some of that. Were you able to find some videos to go after? I've got a list. I'm building a list. If you need some suggestions to go attack some videos that are spreading nonsense about this comet, they're out there. So it's fading? Yes, it is fading. It's not going to... all indications are May 23rd is not going to be a very special day for this comet. It's going to... I mean, when is the closest approach to Earth? Let's take a look at that again from my calculations here. Let's pull up the ephemeris. Close approach to Earth, according to my calculations, should occur around May 24th, 25th. Or, no, sorry, May 23rd, 24th, somewhere around there. Either 23rd or 24th, somewhere in that vicinity. But, no, it's not going... That might be what you're referring to But other than the fact that whatever remains of it will be closest then, I don't think it's going to be super bright. It's probably going to continue dimming, I'm guessing. That's my gut feeling at this point. Oh, you got a couple. Going to hit me up for some more as well? Yes, I will send you some on Twitter after this is over. Let me make a reminder for myself. Remind me at 7 a.m. tomorrow. Send links. Just type it out. No. Cancel. It was listening. All right, we'll try this one more time. Set a reminder for me at 7 a.m. tomorrow. Send links to Comet Atlas videos. Send links to Comet Atlas videos to Dick Dawson. Okay, cool. Just so I don't forget. So, if I forget, by tomorrow morning I'll get a nice little reminder and I'll send you some videos. John Prine is dead. Sorry to hear that. Should I know that name? John Prine. Not familiar. American singer, songwriter. Huh. Country folk singer, songwriter. That's a shame. I'm sorry to say I wasn't familiar with him. Another drink for Mr. Prine, yeah. Bottoms up for Mr. Prine. Have a cheers, have a drink. I think at this point I'm gonna get some food. I've skipped over dinner to get everything ready for this webcast tonight, so I'm gonna go heat up my food and I'll be back with you shortly. But I'll turn up the music here and let you guys enjoy the view of the remnants of Comet Atlas. Move the view up here a little bit, anticipating the comet's future motion. Okay. So enjoy, guys. I will be in the chat, and I will be back after I grab a bite.